When we talk about the unit circle, unit means one. So what we're talking about is a circle that has a radius of one unit. And we are going to define our sine, cos and tan ratios using this unit circle. Now, one important thing that we must remember here is that the x ordinate of the coordinate in this value p is cos theta, and the y value, so we're talking about this value here, is going to be sine theta. So when we basically define the coordinate there, it becomes cos theta and sine theta. Now here's a big diagram. You've got this in your notes of the unit circle. And so we know that this coordinate here is 1, 0. When x is 1, y is 0. And that happens when we are at either 0 or we've gone all the way around to 360. Now remember, the x value is cos theta and the y value is sine theta. So cos of 0 would be equal to 1. Sine of 0 is equal to 0. Okay, it could be cos of 360 degrees. That is 1, because remember, cos is always our x value. And sine of 360 would be 0. Let's go up the top here and use the same information for this one here. So again, we know that this is our cos theta and this is our sine theta. In this case, when you go around the circle 90 degrees, because that's a 90-degree angle, okay, or pi on 2 is a radian, cos of 90 degrees is 0. Sine of 90 degrees is equal to 1. Same could be said, cos of pi on 2 is equal to 0 and sine of pi on 2 is equal to 1. Let's do one more down here and we'll have a look at the bottom bit here, 0, -1. Again, that's our cos theta and that is our sine theta. So what's the angle here? Okay, as degrees it is 270 and as radian it is 3 pi on 2. So we can say that cos of 270 degrees is equal to 0. Sine of 270 degrees is equal to -1. So that's how we use our unit circle. Let's have a go at some examples and see if it becomes a little bit clearer. Now the example says evaluate the following. We shouldn't need to use our calculator here. We should be using our unit circle. Now remember, our unit circle from the last page, if you have a circle like that, you've got 1, 0, 0, 1, -1, 0 and 0, -1, because the radius of my circle is 1. So when I look at cos of 0, 0 degrees is along this line here. Yeah. So cos of 0, I'm looking at the x value of my coordinate, so it would be equal to 1. Cos of pi on 2, now where is pi on 2? Pi on 2 is 90 degrees. So now I am up somewhere else. Where am I? I am up here. That's pi on 2 and it's cos, so I'm looking for the x value there, so that would be equal to 0. Cos of pi. Pi is 180 degrees. It's all the way around my circle. So I'm going to go all the way there. That's 180 degrees. So I'm looking at this coordinate here. Okay, and cos of pi, again, cos is the x value, so it would be -1. And so we go all the way around. Cos of 3 pi on 2, we are now here. 3 pi on 2. Looking at your circle, and you'll be able to get the coordinate very easily. So that's 0. Cos of 2 pi means I've gone all the way back around again to the start, which is here. So therefore my x value, because it's cos, is 1. Let's do the same thing for sine. We're looking at exactly the same angles, but because now it's sine, we want the y value of the coordinate. So the y value, sine theta equals 0, would be equal to 0. Sine of pi on 2 is equal to 1. Sine of pi is equal to 0. It's equal to minus 1, and this one is equal to 0. So these are the x values, and these ones would be the y value of the coordinate. We just have to work out where we are on that coordinate circle, that unit circle. In example 3, we're also evaluating, but look at the angle there in the first one, cos of minus 3 pi on 2. Now, the only thing that's different there is that we are going in a clockwise direction. So from 0, if you go 3 pi on 2, remember each one here is pi on 2, that's pi, or 2 pi on 2, that's 3 pi on 2. So I'm going that way because it is the negative direction. So I'm going to end up here. And what is the coordinate there? The coordinate there is 0, 1, which means that my x value, which is what I want because it's cos, is equal to 0. If I'm going with the next one, sine of minus pi on 2, so I'm going again in a clockwise direction because it's a negative angle, and I go to this point here, and at that particular coordinate it is 0, minus 1 on my circle. I want the y value because it's sine, so my answer would be minus 1. And then we can fill out the other ones, not too difficult because they are going in a forward direction. So 5 pi on 2 would mean that I'm going to go in an anti-clockwise direction, and I have to go around 5 pi on 2, so it would be 1, 2, 3, 4, and I end up back here again. So again, because it is sine, my answer there would be equal to 1. Sine of 9 pi on 2, well, that means I've got to go around 9 quarters. 9 quarters would bring me to where? Again, it's positive, so I'm going in that direction there, but I've got to go around 1, 2, 3, 4, 5, 6, 7, 8, and again I'm ending up in exactly the same spot as what I did the first time around for 5 pi on 2. So therefore my answer needs to be 1 again. 27 pi. Wow. Well, if you think about this one, rather than having to go around individually, if you think about this one, what's actually happening there is that we need to go around to pi, if you like, to pi, because we're going in a clockwise, an anti-clockwise direction. That's pi, and then if you go to there, that is 2 pi. We obviously, every time we go back again, that would be 3 pi, and then back there again would be 4 pi. So really what I want is an odd number because it's 27. And what is the coordinate there? It is when x is minus 1, y is 0. We are looking for the cos of that angle. So we want the x ordinate, and therefore in this case it is minus 1. So we don't need to use our calculator for these angles that are easy to read off from the unit circle. Anything in between those, it then becomes just a little bit more difficult, and that's when we have to start using our calculator to do some working out.